welcome to today's lesson on solutions, suspensions, and colloids, the three types of mixtures we're going to discuss in here. Today we're going to be able to differentiate between those three types of mixtures and then describe the three different types of solutions as well. So let's get started. So for starters, solutions are mixtures that are the same throughout. We call these homogeneous mixtures, which is it's the same word as a homogeneous mixture is a solution. Some properties, some things that make them solutions. They are permanent, meaning this one word sums up the next two, which means they don't settle and they cannot be filtered. So you have the same mixture regardless of whether you let it sit for 3 days or if you filter it out 4 times. And lastly, they do not scatter light. This is called the Tyndall effect. So they don't scatter light, which we'll show you in class. Moving forward, solutions are made up of two different pieces. One is called the solute. This is the stuff that is dissolved, gets dissolved, or there is less of. So if we're talking solids and liquids, the stuff that is dissolved is typically the solid. But if I'm mixing two liquids or two gases, the one that's in greater quantity is the solvent, which is next, and the one in lesser quantity is the solute. So again, our solvent is the component in greater quantity, the one there's more of, or it does the dissolving, is the other way you can think of a solvent. Okay? So along with the parts of a solution, there's three kinds of solutions. So first we have unsaturated. If I have an unsaturated solution, that means that I can dissolve more solute in it. So if I put a salt crystal in there, it's going to dissolve. If I have a saturated solution, that means my liquid has held, or my solvent has held the maximum amount of solute that it can hold. And so if I put more in there, it's not going to do anything. I have my max amount of solute, and then supersaturated. So I can get more, I have the most. Supersaturated is actually you have more solute than initially thought possible, or normally thought possible. And we'll talk about how we can change that as we move forward through this unit. We'll get into that later on. But that's a supersaturated solution. So my question, what happens if I add a couple salt crystals to an unsaturated solution? So if it's unsaturated, remember, it can dissolve more. So these are going to dissolve. Salt will dissolve. If it's saturated, I've held the most I can hold. So these are going to sink to the bottom. And if it's a supersaturated, if you put a salt crystal in there, it actually takes out all the extra stuff comes out of it. And I'll show you a video for that. But takes out extra solute is what it does. Is what that one does. And so those are the three types and what happens if you place a salt crystal in them. This is showing you how salts are dissolved. And so you see here I have positives and negatives. These are like sodium and chlorine. If I take a positive out of here, notice this positive gets surrounded by my negative oxygen. So you're going to have to be able to draw this and use this going forward. So positive, negative, positive, negative. I usually make a 4x4. We're going to make a 2x4 this time. Okay, so this is a negative, gets pulled out here. So I have a negative crystal. This is going to be surrounded by the hydrogen side of water, because remember, the hydrogen side, water's polar, the hydrogen side is slightly positive. So the positive end of hydrogen surrounds this negative molecule. And this force here, this attraction here, is greater than the attraction these had for each other. Okay, and a positive is the opposite. It gets surrounded by the oxygen side of water, because oxygen hogs the electrons from hydrogen and is slightly negative. So you're going to need to be able to draw this diagram, this schematic, simplified, moving forward. But this is how salt dissolves in water. Question, so if I do that, can I get my salt back? And the answer is actually yeah. We have this process called recrystallization, which happens when your water is boiled. So recrystallization is reforming of a solid by boiling water away. So you boil it, you evaporate it out, you're left with just your solid, which will reform as a salt down at the bottom of the container. Might be a mess, might be sticky, but it'll be there. Okay? So here's some examples. So provide an example of each. So a gas and a gas, this would be something like air, would be there. A gas and a liquid would be CO2 and pop. Your liquids can be vinegar, which is acetic acid dissolved in water. Your solids and liquids. So mercury used to be dissolved, or I guess this would be like salt water. Liquids and solids, mercury used to be dissolved into your dental fillings, and then solids are like your metal alloys or your solids. You don't need to write all those down, but it's nice to think of some examples along the way. So here's a chance to pause this, review. What are 2 characteristics of a solution? What are the 3 kinds? And what are 2 components of those solutions? So pause this, and then when you hit play, we'll keep going. Okay, so now we're talking suspensions. Suspensions are heterogeneous mixtures, meaning they're not the same throughout. They have large particles dispersed in a medium. With suspensions, they have some properties. So these settle over time, and they can be filtered. So suspensions settle over time and can be filtered are kind of 2 of their properties, and things that happen with those. Here's an example. So blood is a suspension. If you let it sit, the plasma goes to the top, the red blood cells go to the bottom. And then this is pond water. If you let this sit out for a day or 2, you might actually get clear water with a bunch of stuff down at the bottom, as shocking as that seems. Okay, and our last thing is colloids. Colloids are homogeneous, just like solutions, but they have particles that are a little bit larger, and because of that, they scatter light. And this is called the Tyndall effect, when it does scatter light, as shown here. So you see clear liquid, you see the beam of light, that's called the Tyndall effect. Here are some everyday examples of colloids. My favorite one is fog. So think about driving through the fog. You turn your bright lights on, you can't see anything because all that light is scattered. That is a colloid. Smoke, you can shine a laser through and you see the lasers. Or if you ever watch those movies where somebody's breaking in and there's the laser security system, they put a smoke out and you can see the beams of light. That's the Tyndall effect in action. Okay, here's a quick chart comparison. You should pause this video, get this down. This is your side-by-side comparison of solutions, suspensions, and colloids, which is going to be really good to know. You're going to have to be able to tell me the difference between the 3 of them moving forward. So get this copied down, and then when you hit play, we'll finish up this video. Okay, so here's your last review questions. How would you determine if an unknown mixture is a solution, suspension, or colloid? And what mixture or mixtures exhibit the Tyndall effect? So make sure you can answer those. If you have questions, please ask me when you return to class, and I will see you next time. Thank you very much, and have a great day.